After decades of work, NASA's James Webb Space Telescope, or JWST, is about to start its million-mile journey. The Hubble Space Telescope, launched in 1990, opened up new windows on the universe. But scientists expect that JWST will reveal even more, revolutionizing our understanding of the cosmos and perhaps bringing us closer to answering the age-old question, are we alone?
The whole launch day is going to be filled with emotions. It's an engineering marvel that we as humans, we have never done this before.
I feel very nervous, but excited, and just ready to go.
I mean, there's so much riding on this telescope. It's been decades of work that's gone into it.
It's taken us a long time to get here, but man, we're so excited. We're so ready for this to go. This will be a transformative facility, and it will show us so many things that we just haven't seen.
JWST is the most powerful space telescope ever constructed. With a mirror almost 3 times wider than Hubble's, it'll be able to see objects 10 or even 100 times fainter.
This is the biggest telescope that has been built in space, and because of the complexity of the design. This is no doubt the most complex machine, and it is magnificent.
JWST's mirror is 21 feet wide and made up of 18 different sections that fold up tightly for launch, like origami, and will need to unfold perfectly once in space.
We're not just talking about having to develop lightweight mirrors, but we need 18 of them. They all have to match each other, such that they can be aligned to a degree of accuracy that's, about a 10,000th of a human hair.
While humans see the world through visible light, there are many wavelengths invisible to the human eye, such as X-rays and infrared. Sensing infrared light, which can be detected in the form of heat, JWST will be able to peer through dense clouds of space dust that block visible light, so it can reveal previously hidden secrets of the universe, like early galaxies over 13.5 billion years old, and the formation of stars and planets. And because JWST is an incredibly sensitive infrared telescope, its scientific instruments and detectors need to be kept at extremely cold temperatures to suppress infrared background noise and function properly. To help JWST keep its cool, scientists built a sunshield about the size of a tennis court, nearly 70 feet across when deployed.
Radiation from the sun travels through space. It doesn't care about the fact that the telescope is far away. And so we have to keep the mirrors and the instruments in constant shade, and that's what the sunshield is for.
About 5 days after launch, they'll start to expand the sunshield. Once that's complete, about 10 days after launch, they'll start to unfold the mirror. It'll take 30 days and 1 million miles for JWST to reach its destination. Then it'll start the 6-month cool-down and calibration process. If all goes according to plan, JWST will commence its scientific operations in June 2022. And scientists are excited to see what it finds out about the early universe in the first galaxies.
We're going to see so many points of light from different distances, and that is in itself going to be a revealing moment and how rich the universe truly is and how much is actually going on out there.
With Hubble, we pushed the boundaries to a few 100 million years after the Big Bang. JWST will look past that and will be able to cover the very, very early phases when the first star appear, when the first galaxies are assembled, and the universe that we see today is shaped.
It should also reveal the evolution of stars and planets. JWST's infrared instruments will be able to peer through the kinds of dense dust clouds where star and planet formation begins.
So if we can understand how other planetary systems out there form and where they form, it's gonna be totally revolutionary. We can track its history. So this has profound implications to understanding how our solar system came to be.
And sense the atmospheres of exoplanets.
With JWST, the infrared light allows us to see water vapor in the atmospheres of exoplanets, first of all, but also we can see things like methane and carbon dioxide. And depending on the type of planet that we're looking at, we can actually measure how much of these molecules are in the atmosphere. And that composition can tell us whether there's any indications of the elements of life that could be possible on these exoplanet atmospheres.
I think we'll be surprised how strange and different those planetary systems are. Will we even recognize life? We don't know. I think that the whole point of going to all the trouble of building a telescope as big as JWST is because it provides us with a brand new way to look at the universe. And every time humanity has looked at the universe in a new way, it has been transformative as it has been surprising.